All right, lesson 3.6. We were talking about adding and subtracting fractions in the previous section. Now we are going to throw in our mixed numbers into this. And a couple things, and this is no different from the previous lesson, so I'll just pull it out and then I'm going to put it away. You do need common denominators when dealing with mixed numbers, or at least the fractional parts of mixed numbers. And here you actually have choices of how to deal with these particular problems. And so I'm going to sort of give you the choices, and you will have to try to figure out when the most appropriate is useful. Now in this particular case, the nice part is in A, the fractional parts are given to me in common denominators. So in this particular case, especially addition is a whole lot simpler. The nice part about usually in addition is I can typically just add the whole numbers together, okay, and then add the fractional parts together, but then I have to be aware of what might happen next. So 3 plus 4, well, that is 7, okay, so that is me putting the whole number part together. And then the fractional part together, because I do have common denominators, I can go over 5, and 4 plus 2 is 6. And so now in this particular case, I have 7 and 5/6, or 6/5. Now the small problem with that is we don't want an improper fraction as part of a mixed number. So one thing I have to realize here is this in and of itself is a mixed number. 5 goes into 6 one whole time with 1/5 left over. Remember, this is add, going back to what mixed numbers are. So I have 7 plus 1 1/5. Well, 7 plus 1 is 8. 8 1/5. Okay, so that's one of the ways that I can deal with adding these together. The other way, and again, this depends on how you want to deal with it, as I could change both of these to improper fractions. Okay, and I'm going to do that over here. So improper fraction, IMP fraction, as my computer catches up. Okay, so 5 times 3 is 15 plus 4 is 19, so that's 19/5. Plus 5 times 4 is 20, plus 2 is 22, so 22/5. Okay, if I add these together, we'll stay over 5. And 9 plus 2 is 11, carry a 1. 2 plus 1 is 3, plus 1 is 4, 41/5. And then if I go back to a mixed number, 5 goes into 41 8 whole times. 41 minus 40 leaves me 1. And so there, so I have, and you'll notice both of them end up being 8 1/5. So either way sort of works. You just is how well you work with mixed numbers and improper fractions. All right, so 1 2/5 plus 7 1/6, which even in this case, 1 plus 7 is 8. Okay, which you may want to do. Now in this particular case, just for the sake of writing it out a little bit easier, I'm going to for now leave it as 1, and I'm going to go with a common denominator, in this case probably of 30, because I do need common denominators. So I would be multiplying 15 by 2, so 2 times 2 is 4. And in this particular case, times 5 would give me 30. So my numerator times 5, 1 times 5 is 5. And so now 7 plus 1 gives me that 8 that I had in the first place. 4 plus 5 is 9/30. And then reduce the fraction if you can, and in this case the 9/30 will, because they will both divide by 3. Now the 8 stays, don't have to worry about that, but 9 divides by 3 3 times, and 30 divides by 3 10 times. Now again, I could have done these as as improper fractions. 15 plus 2 is 17, okay, over 15. 6 times 7 is 42, plus 1 is 43 over 6. But I then would have also had to have done my common denominators, which again 30, so double that would be 34, and times 5 here gives me 30, and so I'm multiplying by 5, that's a 5, 5 times 3 is 15, 5 times 4 is 20 plus 1 is 21. Okay, if I add them together over 30, and again, this can get sort of long. 5 plus 4 is 9. 1 plus 3 is 4. And then there leaves me 2. So now how many times does 30 go into 24? Well, that is 8 times. And that what leaves me, oh, 9. 9/30ths, which 8 and 9/30ths again reduces to 8 and 3/10. And so I give you the two ways, and you sort of have to figure out what way works the best. Maybe 1, the best for you, or 2, the best in that particular situation. So, subtraction. And now the issue with, I find with subtraction that I like the mixed, or the improper fraction version better most of the time. And when I get to D here, you'll see what I mean. Now, if you want, you can go ahead and just do the subtraction of fractions directly. In this case, I have common denominators, so 7/9 minus 2/9 will leave me with 5/9. And that's no big deal there. 10 minus 4 is 6, and I have 6 and 5/9, which in this particular case, no big deal. Now, if I try to do that over here, I will need common denominators. In this case, 24 works out fine. 7 times 3 is 21. Actually, I was mistaken. I don't need to worry about borrowing in this particular case. When I glanced at it, I went, oh, I might have to borrow in that particular, oops, sorry, 17. But now if I subtract the fractions, 21 minus 17 leaves me with 4 24ths. I'm running out of space here. 12 minus 5 is 7. But 4 24ths reduces to 7 and 1/6. In that particular case, those will both divide by 4. These both do work as improper fractions if you want to do it that way. Let me go back to the top, and I'm just going to do one of them as an improper fraction. I'll do this one up here. 9 times 10 is 90 plus 7 would be 97 over 9 minus 9 times 4 is 36 plus 2 is 38. That is over 9. Okay, I would then have to subtract them, and if you need to, go to the side or whatever and line them up. Okay, so if I subtract them, I'd have to borrow. 17 minus 8, well, it's 9, right? And 8 minus 3 is 5, so this is 59. Didn't write that down correctly. 59/9. Alright, but if I go to a mixed number, 9 goes into 59 6 times. 6 times 9 is 54. 59 minus 54 is 5, and you'll notice. Okay, so there you go. Then I run into this, and this is where your issues come into play. And going to a improper fraction may be the best, but maybe it's not. And so this is where you have to figure out your math strengths and weaknesses, because when I'm subtracting in with mixed numbers, 3/5 minus 4/5, well, that causes a problem because we can't do 3 minus 4. This is just like going 72.4 minus 63.5 and subtracting them and going up and lining them up and borrowing. Oh, I can't do it because I have to borrow. Okay, so in this particular case, and it may actually be better for you to go 72 3/5 and actually line them up like you would if they were decimals in 4/5 and subtract them this way. Now, here's the deal. 3/5 minus 4/5. In this type of subtraction, you can't do without borrowing. So I am going to do that. I'm going to go to the 72. I'm borrowing a 1 out of 72 and making it 71, and I am bringing that 1 over here to add it into this. Okay, so plus 1. 3/5 plus 1. Okay, the only thing about this is I need 1 as a fraction, which would be 1 over 1. Or the other way that I could write 1 over 1 as a fraction is 5 over 5. Well, because 5 over 5 is equal to 1. If I add that in to my, just like we would if we were subtracting fractions and decimals, I would add that 1 on, right? Well, this ends up being 8/5. Alright, so let me write that over here. So I have 8/5. Well, I now have enough that I can subtract with. 8/5 minus 4/5 is 4/5. So I've taken care of my fractional part, and I had common, and yes, if I needed common denominators, I would have had to change them to fractions with common denominators. And then I keep going, 1 minus 3, well, I can't do that, and this, so I have to borrow, so borrow 1 from the 7, leaves me with 6, add my 1 in, 11 minus 3 is 8. 6 minus 6 is 0. And there we go. So you have to, in this particular case, you may have to do some borrowing. And again, that's where the practice comes in, figuring out which is faster and so on. So, again, this idea of regrouping mixed numbers, okay, and that's what I did in the previous section. Let's say that I was going 72 and, I had 3/5, but I had, down here I was trying to subtract, say it's 34 and 4/5. Okay, and this is what I was talking about on the previous section, is realizing that I can regroup things, because I can't do 3/5 minus 4/5, but I can regroup this value, okay? And so let me do it a little bit slower than I did over there, okay? Remember that 72 and 3/5 is 72 plus 3/5. But I don't have enough here to subtract with. Well, basically what I'm saying is 72 can be written as 71 plus 1 plus my 3/5. Okay? So I've just taken 72 and I've broken it into 71 plus 1. I am borrowing a 1 from this so that I can put these together. Well, 1 can be written as 5/5. Okay? And then 5/5 and 3/5 is 8/5. And I now have enough to do my subtraction with. And so this is now 71 and 8/5. And okay, so it's a matter of realizing that numbers can be broken up and they can be regrouped, and then and we can regroup those fractions and write them as fractions and regroup our fractions to allow us to have enough to subtract with. So, all right, come see me for help. Good luck.